Hello children, in our earlier video we saw that perfect square quadratics such as this x squared plus 6x plus 9 is equal to 0 can be factorized very easily. Just recognizing that it is a perfect square is more than enough to do this. Of course we know what are perfect squares in polynomials. A plus b the whole square is equal to a squared plus 2ab plus b squared. This is x squared, which is the a squared, and 3 squared, which is the b squared, and this is of the form 2ab. So we quickly found the factors to be x plus 3 into x plus 3 is equal to 0. Now, what if they are not perfect squares? We do have many quadratic equations which are not perfect squares. How do we find the roots of these quadratic equations? How do we factorize them? Just let us assume, for example, the same equation x squared plus 6x plus 9, just that the constant term is not 9 anymore. Let's say that it is x squared plus 6x plus maybe 3, right? Plus 3. Now, a factorization method also cannot be adopted. The factors of 3 and 3 are just 3 and 1. Adding 3 and 1, subtracting 3 and 1, nothing would give you 6. So that as to enable us to split the middle term. So factorization is not possible. But let us try to solve this using the perfect squares method. That is, let us try to convert it into a perfect square. Convert this into a perfect square. What is lacking? What is missing in order to make this into a perfect square? Just a 6, a number 6. If you add 6, it becomes a perfect square, right? It becomes 9 and the factors are x plus 3, the whole squared, right? So just add 6, but we cannot add 6 without adding 6 to the other side of the equation also, to the right hand side of the equation also. Otherwise, we would be changing the entire equation. So we've added 6 to both sides. Now let's carry on. This has now become x squared plus 6x plus 9, but instead of being equal to 0, it's become equal to 6. And this can be expressed as x plus 3 the whole square. So the factors are x plus 3 into x plus 3. So this is equal to 6. Now what have we done? We have completed the square. This process is called as completing the square, because it was a 3. It was a 3 initially. 3 was added to x squared plus 6x. We added a 6 more and made it into a perfect square. We completed the square. That is why this method is called the completing the square method. So now our solution is very easy. How do we find the roots? Just take square roots on either sides. Just take square roots on either sides. You get x plus 3 is equal to, what is root of 6? Of course, it's not a perfect square. So it is just plus or minus root 6. So we can, now our roots of this equation are at the point where x, the graph meets the x-axis, is x is equal to minus 3 plus or minus root 6, which is x is equal to minus 3 plus root 6, and the second root is x is equal to minus 3 minus root 6. So see, just by using completing the square, we have found the roots of the equation. This equation could not have been factorized also. So this method, this completing the square method, is a wonderful method, not because it's just easy, it's because it's applicable to all kinds of crazy hard quadratic equations where you can't even factorize the constant term and split the middle term. So I hope you understood, but keep in mind that all these quadratic equations which we dealt with so far have a coefficient 1. The x squared term is 1. Now let's do more examples where the x squared term is, the coefficient of x squared is not just 1, it is any real number. So thank you. I hope you understood.